NASA's about to break new ground like never before by sending a giant drill to Mars. It's the largest drill NASA has ever sent to space, and it will dig deeper into Mars than ever before. The mission? Uncover clues to one of the most outstanding mysteries in our solar system. NASA's $850 million InSight lander is the first designed to study the interior structure of Mars. Until now, NASA's landers mainly focused on exploring Mars's surface for signs of potential life. They've touched down near volcanoes, valleys, and canyons. But InSight won't be going anywhere like that. Since InSight is not a rover and can't move around, NASA has one shot to land it in the perfect spot. Here, Elysium Planitia, sometimes referred to as the biggest parking lot on Mars. It's one of the plainest spots NASA could find, and the perfect place for InSight. For one, it's close to the equator, guaranteeing the solar panels that power InSight's instruments will work year-round for its nearly 2-year mission. But most importantly, that smooth surface will make it easier for InSight's drill to bore deep into the Martian soil. The drill works like a motorized nail, hammering itself into the ground. Over the course of 40 days, the drill will reach 16 feet into the planet. That's roughly the length of a car. For comparison, NASA's Curiosity rover only dug about half an inch deep. That's the length of an aspirin pill. As InSight digs, it will occasionally shoot out bursts of heat. By calculating how quickly that heat warms the ground around it, InSight can measure the chemical makeup of the soil. But InSight's drill pulls double duty. As it hammers away, it also sends vibrations through the ground, which are sensitive to different layers that might be hiding under the surface. For example, if Mars has underground lava flows, those vibrations will find them. But this only gives NASA clues to the shallower layers of Mars. To understand the deep inner core, InSight has another tool that will measure how much Mars wobbles on its axis. It works similar to an egg. If you spin an uncooked egg, the liquid yolk will slosh around, making the egg wobble. But if the inside is cooked, there's less wobble. Similarly, how much Mars wobbles can tell us whether its core is molten liquid or solid metal. And all these clues can help scientists solve a bigger mystery of how rocky planets like Mars and Earth formed in the first place. By studying the interior of Mars, scientists can get a better grasp on how Mars has evolved over billions of years from a warm, wet world to the desolate landscape it is today. But there's an even bigger objective on the horizon. Ultimately, the more we know about our own solar system, the better we get at searching for other planets beyond our solar system that may have the potential to harbor life.